Hello, Junhyung Lee. In the last session, I covered the USB to Universal Asynchronous Receiver Transmitter Converter, and in this session, I will continue to explain features related to Universal Asynchronous Receiver Transmitter. See the ID, the sun. Added before this year in Arduino IDE version 1.66. It's useful and has many applications. That's why I want to explain it in this session. It's a feature called Serial Plotter. Let me show you my computer screen and explain in detail why this Serial Plotter feature is useful and how to use it. Conveniently, I have an Arduino board connected to my PC right now. Let's assume it's receiving some sensor values. I've set it up to send some fluctuating values. So let's open the serial monitor. I've enabled serial communication. But when you look at these values, can you immediately grasp how they are changing? Of course, some of you might be able to understand the changes just by looking at the values, but many might find it difficult due to the rapid changes. So, let me show you another feature. I'll close this. And this feature is available in Arduino Integrated Development Environment version 1.66, 66.6 and above. I'm using Arduino IDE version 1, 8.9 from the Tools menu. Simply click on Serial Plotter and it will display the values as a graph. When you were looking at the values in the serial monitor, it was hard to grasp how they were changing, but now, with the graph, you can clearly see the changes. This is how the Serial Plotter feature helps users understand the values received via Universal Asynchronous Receiver Transmitter communication more easily. It's also quite simple to use. I'll close this and show you two pieces of code I prepared. First, let's look at the code I just ran. It's the same as any other Arduino serial communication code. It starts with a serial baud rate of 9600 and continuously changes the values using a sine wave. The key point is to print the values you want using serial.println. The difference between serial.print and serial.println is that serial.print just sends the text via serial communication, while serial.println sends the text followed by a new line character, as indicated by the ln in its name. The symbols related to line breaks are y, \r, \n. So if you are using Arduino, you can simply use println to send the values. However, if you are using another device for Universal Asynchronous Receiver Transmitter communication and want to utilize the serial plotter on the Arduino side, you can send the values followed by \r, \n. This way, when you connect it to the Arduino Integrated Development Environment, you can easily view it as a graph using the serial plotter. This is how I have set it up. Similarly, you can view these codes by following the link provided below, and in my case, I only checked one type of value, but of course, even checking just this one type of value can be very helpful. For example, when checking an inertial measurement unit, an accelerometer, or was a gyroscope, or even when checking if a button is pressed, or when using a light sensor, it would be convenient if the graph moves back and forth, even if there is only one axis of data. However, in the case of an inertial measurement unit, for instance, there can be 3 or 6 axes. So, if you want to view multiple angles simultaneously, you can also use the serial plotter. If you look at the code next to it, the setup part is the same, but the difference is that I have set it up to send 3 values as if they were 3 columns. So it sends 1, then a tab, 2, then a tab, 3, and then a new line, let's run it on the serial plotter. When you run it on the serial plotter, you can see multiple values on a single graph simultaneously. A downside is that you can't label what each value represents, but you can identify them by color. The first value is blue, the second is red, and the third is green. Sometimes, due to glitches in universal asynchronous receiver-transmitter communication, it may appear as if 4 values are being received, but you can ignore that. For demonstration purposes, the first value is 1, the second value is 2, and the third value is 3. Although we send fixed constants, if you are using an inertial measurement unit such as a 3-axis sensor or even a more complex 6-axis sensor to check values, you can very easily understand all of the trends of any changes occurring over time using the serial plotter graph, even if these values change at the same time simultaneously. To explain again in detail, if you just want to see only a single value represented as a graph, you only need to use one single println command. And if you are sending universal asynchronous receiver-transmitter data from another device other than Arduino itself, you should send each value followed immediately by both \r and \n characters. If on occasion you want or need to send multiple different values, then it is best practice that they be separated them with tabs, spaces or commas, and then add one final println at the end. Alternatively, for other hardware systems, add double backslashes followed by n. This way, indeed, you can conveniently view your desired graph in real time within the serial plotter interface. We have now looked thoroughly at this useful serial plotter feature during our session this time. I hope you will. Definitely try using the serial plotter feature when you develop hardware. I will see you in another video next time. See you then.